So, we've discussed the user interface and setting up your workspace and support files, and I really want to talk about templates next before we get into model space versus paper space and other things. So, the templates, well, first I just want to make a brief statement about CAD and the importance of what it is that we do. When it comes to our job, either as dam designers or foundation designers or tunnel designers and engineers and H&H, every aspect of what we do, besides some small reports and things like that, most of what we do ends up going into building something. And when it comes to building the site that we're working on, the contractors are going to be using what we generate in CAD, the drawings that we generate in CAD every single day to get what they need to get what they're contracted to build done correctly. Of course, we have specs and design reports and a whole bunch of other stuff that a lot of our people put a lot of time into. But when it comes right down to it, the drawings are the go-to for the contractors when it comes to getting the information that they need to build what we're asking them to build, what we've designed. So CAD's a pretty darn critical step in that process. And it's really important that we take the time to make sure that the stuff that we're doing is accurate and reasonable and legible and can serve that purpose, so that that we can keep ourselves and our company in good standing. We have a pretty great reputation in the dam industry. Schnabel does, and Lachelle and the tunneling industry, and we'd like to keep it that way. And one way we do that is by having everybody see the importance of the design work that they do in CAD and understand that that there's a lot riding on it. So one of the reasons for hosting these classes over the next couple of days is to try and get as many of you as familiar as possible with these tools and how to successfully use them and be comfortable with them so that you can perform your own designs within CAD and not have to rely on somebody like myself, a dedicated CAD user, to get your designs done for you. We have very few dedicated CAD designers throughout the company, and rely on a lot of young engineers and scientists to do CAD work, to perform their own designs within Civil 3D. So, to do this right, we need to start off with the right template. And there are two main templates that we use every single day here in the Greensboro office. And to access these templates, you would go to the File drop-down and go to New. This is a different command than the QNew button, the icon up here. When you see that, you hover over it, it says New, creates a blank drawing file, and it says QNew. You could also type that in if you wanted to quickly access it. But just to let you know, the QNew template is driven from these support files that we were talking about just a moment ago before the break. You see here, default template file name for QNew. It's pointing to our SE Civil 3D _ 2012.dwt. DWT is the file extension for all templates. So when I hit QNew, it's automatically going to open that template, the Civil 3D template. For one of our structural engineers who's just joined us, when he hits QNew, it opens up a separate template, and we're going to show you that now by going to File, maybe, File, New, and it's going to bring up a list of templates on that server location. Now there are 4 templates in here, one Plan Production Tools and one for Arch 2012 Inch. But the 2 main templates that we're going to be using day in and day out are C3D and Detailed DWG. Now we already have Drawing 2 open here that is based on the C3D template. I'm going to go and open up the Detailed DWG template to show you a few differences between the two and where and why we use each one. Okay, that's going to take a moment to open. But the first thing I'm going to point out is with the Civil 3D template is that we have in that template built in over 100 layers. Now, layers are a way to organize our drawing and to assign certain settings to objects automatically just by nature of what layer it's on. So going back to the Civil 3D template, we can see when you open the Civil 3D template, it opens you into model space, and you see a standard Schnabel north arrow, nifty little object that allows you to rotate it based on any angle that you would like. And then a short note here from me about the template and about, if you have any questions, emailing or calling me. The reason this opens to paper space is so that you can know that you're in the correct template when you hit Q New. If for some reason you didn't have a link to the K drive or to your server drive, you may not know that you're in the correct template. So if we were to open up our layers manager, that's this. So this was our layers drop down. You can see we've got a lot of layers in here already. If we want to look at them all, you can click this button off to the left, and this is the layers manager. Now, as we can see here, there's 160 total layers within the Civil 3D template. Now, each one of these layers, for the most part, is being used by a style that's already set up within our template. Now, styles are what make everything look the way it's supposed to look, and they take a long time to create and develop within the template itself. And the layers are a way of organizing those styles. And as you can see on any given layer, we have a color and a line type associated with it. There are also a number of icons in terms of whether that layer is on or off, whether it's frozen or unfrozen, or whether it's frozen in a viewport. That's what VP freeze stands for. You can also lock layers and assign multiple different types of settings, properties, so to speak, through the layer menu. Last thing I'd like to point out is this little red cross that's over the printer icon. That means that this layer, C align no plot, is going to not ever plot in your paper space at all. Even if you're showing it clearly in model space, it will not plot. There's always a default non-plot layer that's called def points. And you can see on this one the printer icon is completely grayed out. There's no X on it. It's a default no plot layer. So if you're using line work or text or objects that you don't want to ever show up in your final print, you're free to use the def points layer. Okay? So if we move over to drawing 3, which we started from the detailed DWG, we'll notice a few differences. One is it starts out in model space. 2, there's a very small number of layers in this list. I think 9 total, 10 layers. All right, 0 is a default layer, and def points is a default layer. The rest have been generated by us for commonly used layers within our space. So that is our 2 basic templates, the Civil 3D and the detailed DWG templates, and I'm going to tell you now what we use each one for. Basically, if your drawing contains a surface and alignment, Kogo points, profiles, profile views, sections or section views, pipe networks, or parcels, you're going to want to use the Civil 3D template. But for all other drawings, this will include most of your XREFs, your title block drawings, your cover page, your legend sheet, almost any other type of drawing that does not need to contain all of your structural drawings for the most part, and a lot of your detailed drawings, are just not going to need to start in the Civil 3D template. You don't need that huge bloated layer list, you don't need all the styles, and you want to just start with your detailed DWG if you're doing just a plain Jane set of 2D line work for your project. So say your limits of disturbance, your 2D line work existing, your 2D line work proposed, some of your ENS symbology and line work can all go into an XREF that starts with a detailed DWG. And that's hugely beneficial because as you bring more and more XREFs into a drawing, XREFs are something we'll cover in just a bit, you'll notice that this layer list is just going to get bigger and bigger and bigger because it's bringing in all of the layers for each one of those XREFs as well. And so it's important to keep that list manageable by using the correct template when you start. Do we have any questions on templates or the detailed DWG template versus the Civil 3D template? This is probably, I think, one of the most important things that we can have everybody understand today, is that we have two different templates for a reason, and it's really, really important that you start off with the right template. And if you find that you're working on a project where people are using the Civil 3D template and they should have used the detailed DWG template, it's really easy to copy and paste those to original coordinates to get that into the correct environment that it should be. There's also a trick if, for instance, you're working in a detailed DWG template and you suddenly realize that you're going to need surfaces, alignments, or other things that are style-based. There is a trick to be able to get those styles into that detailed DWG template, and it's pretty easy to do. And I often will keep a copy of this on my desktop. So again, we started here with the Civil 3D template. It's just a blank drawing. There's nothing in it except for these two objects in paper space. Even though it has a big bloated layer list, it's, all of that is based on the huge number of styles. Just to give you a preview of all of the styles that we're talking about here, I mean, we've got surface styles, label styles for surfaces, contour and slope label styles. We've got alignment styles, table styles. All of this is style-based, and for each one of these styles, they need layers, specific layers to go on. That's why we have such a big layer list. But if you were to open up a blank Civil 3D template and do a save as, literally there's nothing in this drawing, and I'm just going to save as. I'm not going to save it as a template, but I'm just going to save it to my desktop as C3D. Oops. Oh, it saved it as drawing 2. Sorry. We're going to save that as C3D as a regular .dwg drawing right to my desktop. And then over here in the detailed DWG, if I were to try to create a surface in this detailed DWG, the styles just simply don't exist for that to happen. I'll show you what I mean by, I'm going to copy some line work from an open drawing. This is a survey we received recently with, looks like they've got, oops. All right, they've got some 2D polylines at elevation. That's good. I'm going to select just a major and a minor contour, and then right-click and say Select Similar. This will grab all of the contours for the survey, and then I'll right-click, go to Clipboard, Copy. Control-C works just as well as is going to Edit, Copy. So now that those are copied to the clipboard, I'll go back into our detailed DWG template, and I'll paste those to original coordinates. If you're ever trying to paste this block or paste to original coordinates from the right-click menu and you notice that you can't, for instance, paste this block is grayed out here, you can always go up to your Edit menu and usually find that it's available from that Edit menu. For some reason, the right-click context menu just won't work on occasion for paste to original coordinates or paste this block, but if it happens, go up to your Edit menu, use that drop-down. So this is going to paste those contours into the exact same XYZ coordinates for that it was in the survey. Now, creating a surface from this even within the detailed DWG template is possible, but it won't allow us to assign any styles. And so what I'll do here to create a surface, I know we're getting into Civil 3D stuff, and I sort of promised we wouldn't do that today, but I can't help myself. So I'm going to right-click. Again, I've got this thing called the Tool Space open. It's accessible through the Home tab, where all the other palettes are saved. It's the big button here for Tool Space. I'm going to right-click on the surfaces and say Create Surface. I get a pop-up here where we can name the surface, and I'm going to call this EG, the abbreviation for Existing Grade. Now we see here under Style, there's only one style available for this because I'm in the detailed DWG, and that's standard. Standard styles can't be deleted from the template, so I can't make any changes to that style. The other thing I'd like to point out is that this surface is being created on the 0 layer, That's because that's the current layer I'm on, and it can be changed through this. If you were in our Civil 3D template, this would behave entirely differently because there are command settings to place every newly created surface on its own individual layer, which is very powerful and very helpful. But we'll go and go through this exercise so I can show you what I'm talking about here with this nifty little trick. So we're going to create the EG surface, standard style. If we were to look at this surface, we would see that there's nothing there. If I go to surface properties, there's no statistics about it because there's no data in the surface yet. But what I'll do very quickly is grab all of these polylines from the surveyor, major and minor contours, and expand the definition of this surface, and right-click on contours and go to Add. And when you're adding contour data, you get a pop-up that will allow you to change some settings. We almost always go with the defaults on this. If anybody would like further explanation on weeding and supplementing factors or any of these other settings about flat areas, I'll be glad to talk to them one-on-one. But we'll accept the defaults as we normally do on this and hit OK. As we can see, even if we select this surface, it tells us in our properties menu that we have a surface selected and it's set to a standard style. We can't see it. There's nothing highlighted. There's nothing telling us that the surface is actually there because it's based on a standard style which gives no display properties. But to get our Civil 3D settings into this detailed DWG template, I'm going to use the Insert menu to insert, enter, and I'm going to browse to the desktop. And find that C3D, which was the blank Civil 3D template drawing that we saved to the desktop. And I'm going to insert that as a block. Now this is going to think for a minute because I just add hundreds of styles to the drawing definition. And now, if we were to select this surface, you'll see that I have a whole list of styles to choose from. And now suddenly we have a surface that we can select and analyze and change the styles. So we have contours 1 and 5 existing, 1 and 5 proposed. We see the colors change there. All of that's available because I inserted the Civil 3D drawing from my desktop into that work environment. And you'll see over here as well, we went from a 10-layer list back up to 168 layers just by nature of inserting that Civil 3D. Now, this is all an example just to show you how you can get your Civil 3D styles and everything into a detailed DWG template drawing if you were needed to do that. The preferred method, of course, would be to start with your Civil 3D template and work from there. And I'll show you why. Because we inserted all of this into the detailed DWG template, this drawing is still, this surface is still on layer 0. It tells us here in the layers drop down in the layers toolbar, as well as over here in the properties palette that we're on layer 0. If we were to do the same exact process in this drawing, which started from the Civil 3D template, paste original coordinates, I'll go ahead and select all of these polylines, create my surface. Now, what you'll notice up here in the surface layer is that it's already filled in the information, and it's not based on our current layer. It's filling in, it says C-topo-asterisk. The asterisk is because it's going to name it, that layer. It's going to create a new layer named on our current given surface name. So when I hit OK here, and then add the surface definition, the contours to the surface definition, we can see that it automatically created a surface on a designated style. And I'm going to just select this surface and bring it to the front. And that's a 2 and 10 foot, still wanted to select, that's a 2 and 10 foot surface style. And you see our surveyor provided us 1 foot contours. So we can change that to 1 and 5 existing or 1 and 5 proposed and see how closely we line up with the given line work. It looks like we're really close, if not on the money, everywhere. Maybe small areas. Yep. So we see we have some boundary conditions and things we need to work on to get this refined. Our contour data, again, if I send this to the back, our contour data ends here. You can see it just grayed out there, there, and there. We would need to refine this surface based on boundary conditions to get it to do exactly what we want. All right, so we have touched on a little bit of Civil 3D, even though I promised not to for today. Let's go back to my reminder. So we're talking about templates still. Okay. Tomorrow and Wednesday we'll be talking a lot more about the Civil 3D templates and specifically and about how to leverage a lot of the tools within that, the styles within that. For now, we're going to move on to some of the basics of CAD, including the CAD natives and modify commands. For a lot of people, this is going to be review material. You know, it's going to be a refresher because you've worked with this and you know how these things work. But I hope to show y'all at least one or two things that you may not know about both the draw and modify tools that are the most common in AutoCAD. So here we have one of our documents on our Lunch and Learn series that's called AutoCAD Native Objects and Commands. What this document does is it outlines every single command within the Draw toolbar and within the Modify toolbar. But it also gives you what the command is called, what the icon looks like, but also gives you the keyboard shortcut for each command that is there. I highly recommend people to memorize a few of these. You know, I don't use keyboard shortcuts for everything, but it can be very helpful and much quicker to use keyboard shortcuts. There's a brief description of each command, and each command is also hyperlinked to the online help file for that object. So we have lines and polylines and a very thorough discussion on the knowledge base of Autodesk about what each one of those, each object or each command contains. In this own document, I have a brief discussion about lines versus 2D polylines versus 3D polylines. The 3D polyline is not in your Draw toolbar, but it can be accessed through the command 3D poly, typed out on your keyboard. And what I'd like to highly recommend for all users of Civil 3D and CAD is that we sort of ignore this first line command. There are a lot of people that still use it quite a bit, but for many, many reasons, I'd like everyone to use polylines as opposed to lines. And just to give you a brief example of why that is, let's go and start a new detailed DWG template, and I'll get into what the main benefits of using polylines over lines are. I'll give this just a minute. A lot of old school guys will, you'll notice, will use the line command. And I'm going to go and start a line here, and I'll draw it 5 units vertically and 5 units horizontally. And we'll just draw a nice little square here. And so what we have are, with the line command, are 4 individual objects that are really only associated to each other by having shared vertices at each corner. But there's not a lot of benefit to having these 4 lines in a drawing. We can't really, in other words, we can't really do much with these 4 lines. However, if I were to start the same command with a polyline, and I'll go 5 units down, 5 units over to the right, 5 units up. Now, I'm going to close this polyline incorrectly so that I can show you how to do it correctly. And incorrectly, by incorrectly, I mean I'm going to go and snap over here on this last vertices to quote-unquote close the polyline. Now we see, instead of the 4 individual objects that we have with our line command, we have a single polyline command that it gives us the same amount of data, but it gives us a lot more helpful information. Now you see under here, under closed, under the properties menu, it says no. Now I could technically click on this and say yes, but that would be a mistake. But I do want to point out that having this semi-closed polyline does give us more information. It gives us the total length around it, along with the area in square units for this drawing. So for 5 by 5 by 5 by 5 square, we have a 25 square unit, square foot drawing, square foot box. Now, since I did not close that properly, you see, if I were to grab the midpoint of this polyline and drag it up, we can tell that it's not closed. All right, and now we lose some information in terms of accuracy, in terms of what this is trying to represent. So what I'd like everybody to try to remember is that when we're drawing polylines that we want to be a closed polyline, whether it's a structural or for a wetlands boundary or for any other purpose, if it's intended to be closed, I would like us to, if you're drawing it at the time, before you click over here on your last vertices, is to simply just right-click and use the close context command within the right-click menu. Now when we click on this, we see that the closed variable is set to yes, and if we were to drag on any piece of this to modify its shape, it will maintain its closed nature, and all of its data in terms of area and total length would be updated accordingly. Okay? Some other benefits to using the closed polylines are that we can make some really cool stuff with it. All right, what I'm doing here is holding down the Shift key and then doing a free rotate in 3D space around my model by holding down the mouse wheel. You're zooming in and out with the mouse wheel, but if I hold down the Shift key and then click down on the mouse wheel, it gives me the ability to free rotate around a 3D model. If you're working off of a laptop or an older desktop and you have a lot of objects in your drawing, I don't recommend doing this. Free rotate will certainly crash your computer if you've got civil 3D surfaces and other complicated objects going on. But with this simple amount of line work, I'm able to free rotate pretty freely without messing up anything or crashing the program or my computer. So with a closed polyline, we can actually turn that into a number of different things. We could set its elevation. We could create copies of it at different elevations. We can do a bunch of nifty things. What I'm going to show you now is some basic 3D modeling within CAD itself. And I'm going to use a command called extrude. All right. And what this does is, because I had that polyline, that closed polyline already selected, when I type the command extrude, it allows me to create a 3D object. All right. And this is a live 3D object. And because I'm in this isometric view, after my free rotate command, I'm able to set a height for this box. So we'll set it at 5 units high. I think it should have set at 5 units high. Let's check. Yep. So now we have this nifty little box, and we can click over here and see the 3D nature and change our view styles from 2D wireframe, which is default, to conceptual or hidden, realistic. Doesn't that look real to you guys? It's almost like a photo. Shaded with edges. All these different styles are just for your use when you're working with 3D objects. We'll go back to 2D wireframe for now. And the reason I'm showing you all some very rudimentary 3D stuff is actually came by request from our Westchester office. That Courtney and others have noticed that a number of other firms, outside firms, that he's noticed a number of isometric detailing going on in their drawings. Now 3D objects and drafting in 3D is actually really simple and can be a lot of fun if you like doing this sort of thing and think it's fun. But and it can have a very big impact on your drawings to be able to include some nature of 3D aspect on your drawings. So I'm going to go back to a plan view. I'm going to click on the view cube here and then rotate it back to true north. That's what all of this is doing. And I'm going to draw myself another rectangle on top of this box. I'm going to select it, make sure I've got it and not the box selected. I'm just going to change the color briefly so that I can tell the two from apart. It did draw it on the top, not the bottom. That's good. And what I'm going to do here is just offset this rectangle a little bit. So we're going to grab our offset command. A lot of my commands are hidden because of the screen size here. Type in offset to get it there. Oh, that's my draw toolbar. Not what I want. Sorry. So again, we'll use the offset command here to offset this red line by a small distance. Okay, so we now have two copies of that. That one is offset by 0.25 units in all directions. And what I'm going to do, I'm going to use the extrude command on this inside one again, and I'm going to extract that down to the bottom. I'm going to snap using my O-snap commands to the bottom of this. And if we were to look at it straight on, that bottom line would pretty much disappear because they're at the same elevation. Maybe I want that to be a little bit higher, and I'll raise it up. What I'm going to do now, guys, is I'm going to go ahead and subtract one from the other. Essentially what I'm doing here is creating a rudimentary V-notch weir box that's used in a lot of our instrumentation and other details. And we've seen these in 3D on some people's plans, and I'm just showing you how to pretty quickly create your own. Okay? So what I have is the outside box and now an inside box. And we could subtract one from the other to create an open lid box that's not closed. So again, just to remind everybody, if we were to turn on some of this, we see that this is just a flat box on all sides, a cardboard box, so to speak. But with the two different ones, I may need a different toolbar. We have a solid editing toolbar that I'm going to pull up. And what we're going to use here are some of the Boolean commands. And I'm going to use the Boolean subtract command. So I'm going to start off by selecting the first outer box, and then selecting the subtract command here, and then basically subtracting that inner box from its geometry. Did it work? I don't think it worked. Nope. I've actually had a lot better luck. So just as a brief primer for you guys, when you use the extrude command, your eventual output is what's known as a 3D solid. This is very beneficial for a lot of reasons, but when it comes to editing these 3D objects, I much prefer using mass elements, and they're interchangeable. 3D solids can go to mass elements can go to 3D solids, and it's very easy to do so. So with this first 3D solid selected, I'm going to click on Convert to Mass Element, and I'm going to ask it to erase the layout geometry, and then just go with the description, and I'm not even going to do anything for the description. So now it's a mass element. It tells us it's a mass element properties, and it's giving us a slightly different look to in terms of the grips and other features of this. And I don't think I need to do it for the center one. I'm going to leave it as a 3D solid. But now when I right-click when I select the mass element and right-click, I get these Boolean commands. Same commands that are up here, but they tend to work a little bit easier with massing elements. I'm going to go to Boolean subtract and select that inner box 3D solid again, and ask me to erase layout geometry. I'll say yes. All right, now I think this worked. Let's take a look. It created a composite object that is now a hollow box. Okay? Pretty much what I wanted, at least to start with. The last thing I'm going to do to create the V-notch weir detail is to create a V. So I'm going to draw myself a little guideline here, and then again, I'm in a elevation view, so to speak, of this. And again, I'm going to use my polar commands, polar snapping, to snap to a 45-degree angle, and then use tracking to snap to both the top and to a 45-degree angle. And then I'm going to just end it right there, and it's just part of a triangle, and then use a mirror command to mirror it to the other side. Back into a free rotate, and we have this series of line work that isn't doing us much good yet. So what I'm going to do now is join these two pieces of line work together using the join command. So we have a polyline selected, and I type in join. It asks us what it would like to join to. Oh no. Well, that's not going to work. We're going to go back to our front view and redraw that polyline in a different color. And right-click to use to close. So now we've got a closed polyline in green. And what I'm going to do with this is extrude again. And just create a brief, I wanted to do a little bit more than that. I wanted to go all the way through. And now I'm going to use the subtract command as well. Again, this is still a mass element. Right-click, Boolean subtraction, and I can subtract that. I'll choose yes, it'll delete everything. And now we have this nifty little isometric V-notch weir box. Okay? Now, if I was to insert a detail of this onto my drawing, what I would likely do is actually use another command called a flat shot command. All right, so typically how I use flat shot is I'll go from an isometric angle that I want to display on my drawings and start off my view cube with an isometric angle just by clicking on any one of these corners. So I've got a sort of a southeast isometric view set up, and I'm going to type in the command flat shot. Oh, I just realized this isn't going to work with a mass element. I need to quickly convert it back to a 3D solid. Erase layout geometry, yes, and now we have the exact same geometry but in a different object type of a 3D solid. All right, now I can do my flat shot command. We get a pop-up that's asking us to, if we want to insert a new block or export it to a file or replace an existing block. And I'm going to set this so that I want my foreground colors to be green, and I want to show obscured lines and have them be red, and let's go with hidden too, if I can find it quickly enough. Okay, and I'll hit create. Ask me, where do you want to put this puppy? I'll just pop it there and then hit enter, enter, enter to select the default scale and rotation. Now if we were to go back to a plan view, we see that we have this very slick looking isometric view of that 3D object. But it's perfectly flat. It's a flat shot of that 3D object. I know this is a very simple example, but this is something that we use quite frequently in our structural drawings. It's a good example, Jernigan, maybe Cobb's.
Yeah, I think Cobb's.
I'm going to show you a brief example of how we use this in our everyday structural drafting. Yeah, no addendums. See if we use it here. So this is a small example, but this is a complicated piece of pipe with a custom-made Y, and it has a crotch plate in it. And you know, you could look at this set of drawings that Robert Jernigan and I put together for an hour or more, and not figure out as quickly and easily what it looks like based on this simple isometric view. That's a pretty simple example. I'll see if I can quickly find some others. That's somebody else's drawing. Here's some other examples of an inlet-outlet tower where we use the flat shot command on 3D objects to generate those views. And as you can see down here, we use a very small version of that isometric view of the flat shot to highlight which area of the tower is being worked on this sheet. So everything in this view, everything on the sheet is covering this first block of the build of that tower. Another flat shot of a pretty simple bridge corbel being used on the abutment side of the embankment or on the embankment itself. There's that Y we just looked at earlier. Here's a pretty cool one. This is the box inlet spillway, and that's just a 3D object that's been turned into a flat shot to show very quickly and easily, even to non-construction people, non-engineers, exactly what this completed structure is going to look like. So you can see we rely on these pretty heavily in terms of keys, view keys, and other things. And, you know, honestly, it just makes our drawings look sick as shit, and that's why we use them. All right. Do we have any questions from anybody about these rudimentary 3D tools, about templates, about anything that we've covered so far? Okay. So we've talked a bit about CAD natives and modify commands. We haven't covered all of that stuff. So I do highly recommend that people review these documents and check out the online help documents, do tutorials, and to read up on this stuff as much as they can. I do, before we move on from these two basics of the draw and modify toolbars, I do want to show you all very quickly something about the rotate and the mirror command. It can also be used for the scale command, and that's how to use reference geometry when you're rotating. This is something that I was taught very, very early in my CAD career, but I've realized as I help others with their working in CAD that they may not know it exists, right? So when it comes to rotating based on a reference, so again, we're using our modify toolbar, which is this one right here. The rotation command is right here. And just using it, let's go to the polyline, and we'll close that real quick. I'm also going to remove this extra vertices. All right, so we have a nice little rectangular polyline here, and I'm going to select the rotate command, and I'm going to select a base point to rotate that. Now, if that's all I do, I can just free rotate this object in 2D plan space at any angle I want. And if I type in a, it's because I have polar tracking selected, it's going to automatically snap to those 45-degree snap lines. If I were to change this on the fly, even during the rotate command, I could have it snap to 30 degrees. And if I knew the exact rotation value, if I wanted it to be 22.7 degrees, I could type that in, and because I have dynamic input in, I can see that 22.7 pop up right there by my cursor, and it's going to rotate to exactly that value. And if we wanted to check it, we go up to our annotate toolbar, do this drop down here, and get our angular dimension. So
precision. Such your precision.
Yeah, I thought I chose 27. That may be in the opposite direction then. Precision. 22.7 degrees. Okay.
Counterclockwise, it's positive.
Yeah. That's right. So, but to rotate an object based on reference geometry, it's a slightly different process. So my end goal here is I want to rotate this rectangle back down to this green line. I have the green line there as a reference, and yes, I know the angle, but I really just want to show you all how to do this as a reference because it's extremely helpful. So again, I'm going to pick the base point after I've selected the rotate command. So just to walk you through it again, first thing first, I'll select the geometry, and then select the rotate command. And we see in my context here, both at the bottom of the command line, specify base point, and at my cursor input, it says specify base point. I will select that base point, but before I start rotating, I'm actually going to type in the R key. This, you will find actually that there's a drop down available when you have dynamic input on to go to your last inputted, it's abbreviated, but your last inputted angle, a copy or reference. I actually want to do a reference angle. So I'll show you in just a second. Again, select, choose your command, and then your base point. Now, because I have dynamic input on, there's a small, what looks like a down arrow next to the dynamic input where it says specify rotation angle or. Now that or has to do with your options. Now down at the very bottom down here, guys, the or is taken up by your options already listed there. It says or copy or reference. Okay? And so I'm going to do reference. And again, to get to that, I can hit down on my arrow key and do that, or I can just type in R for reference and then hit enter. Once you've chosen reference, you need to repick your base point. And then from there, pick the second point along this reference geometry, along the geometry that you're going to use to rotate. In this case, I'm going to choose this other endpoint, and then I'm going to rotate it down to this piece of reference geometry. I can either let it snap to the 0 degrees based on polar settings, or I can snap it to the geometry itself. You see, because of dynamic dimensioning, this dimension automatically updated to 180 degrees. I'm going to delete that. But I wanted to show you guys that because it is extremely powerful. And it's so much quicker when you're trying to get objects rotated and set up based on stuff that's already there. 90% of the time, it is going to be based on stuff that's already there. Now, I'm just repeating this command, but here I wanted to reference something that's well off of its snap plane. It's way over here. I just wanted to rotate to that specific angle, so it's snapping to that outside box. And you see that's very easy to do. And it would be difficult to determine that angle on your own. So that is rotating based on off of reference geometry. The same thing can be done with mirroring command. If we were to mirror this object, you could, of course, use polar to mirror it based on any of your polar snap settings. Mirroring with polar snap of 45 is extremely helpful when doing certain geometry. So you can see here, it's going to create nice little, comfy little quadrants. When you're doing the mirror command, it also gives you an option to erase the source geometry or not. So you can make copies as you're mirroring things around. Do we have any questions on these basics of the Modify toolbar? How impressed is everybody by the 3D rear box? I mean, that's impressive, right? Pretty cool. All right, everybody online hanging with me and doing okay? I haven't seen any questions come through, but I think what we're covering so far is the pretty basic stuff. Courtney had asked me specifically to cover this sort of thing, 3D drafting. Just remember that any 3D closed polyline can be converted into a 3D solid or a massing element. The command for directly creating a massing element is very similar to the creating a 3D solid. Just as a refresher, we selected the line work and then typed in extrude to create a 3D solid. If we want to natively create a massing element, we would choose this next command in the list called extrude line work. When that's selected, it asks us if we'd like to erase the selected line work, and then instead of a live input of how tall we want this thing, like a 3D solid does, like the extrude command does, it asks us specifically how tall we want it. I'll type in 5 and then enter, and then we natively get a 3D massing element as opposed to a 3D solid, but the two objects are easily converted back and forth through the right-click menu, convert to 3D solid. Now, massing elements have a lot of benefits when it comes to adding and subtracting them together to make more complex objects. Both allow you to have grips to push and pull in various directions. And both 3D solids, when you hold down the control key, so selecting the 3D solid gives you a look that looks like this, where each of the vertices is highlighted in these dark blue grips. But if you were to hold down the control key on a 3D and then select on a 3D solid, it actually allows you to select and then manipulate through the grips various faces. Everybody seeing how that works? So with a 3D solid, I can select individual faces and manipulate them individually. And that's just handled slightly differently than on the massing element. Massing element gives you grips, And those you can cycle through to do various different options by tapping the control key. So here it's basically extending those angles out and creating a bigger base for that object. If I tap the control key, it will create a point or a triangle based on that, grabbing that midpoint. Tapping it again creates a radius. Tapping it again creates a full offset of that entire object. So cycling through the control keys while grabbing massing element edges does that. Cycling through the control key while grabbing one of the grip arrows does nothing. All right, I'm going to assume we have no further questions on that stuff, or nobody's going to want any more examples of how that works. But I hope that's helpful for you guys to know how. Apparently I lost my V-notch weird when I started messing with that, the top of that 3D solid. Y'all notice that? I guess this was snapped up here, and by pulling it down below the V-notch, I essentially made the V-notch disappear. Interesting. But because this flat shot, oops, the flat shot is basically a snapshot of whatever objects that you had generated at that time, whatever 3D solids are in your drawing at that time. It's going to stay exactly the way it is, and there's no way to update it automatically without going back through the flat shot command and asking it to replace this block. Clear as mud, right? Laura, you doing okay? Mm-hmm. Moving right along. So we've discussed CAD natives and modify commands. Let's talk a bit about layers. You'll notice that I was pretty lazy in all of these examples. I didn't go in and create my own custom layers as we drew these objects. But I should have. In fact, I did another bad thing. I changed the property of an object without creating a new layer first. This is bad CAD, guys. All right, maybe I did it on purpose so I could show you what bad CAD is all about. But in general, we want most objects in our drawing to be on their own layer or on a shared layer with other similar objects. And it's pretty easy to do that. We're in the detailed DWG template, so we have a very short layer list. But what I'd like everybody to get in the habit of doing is when they're working on projects is creating their own user layers, or before they start drawing something, to select an already existing layer that makes sense. Now, when you're in the Civil 3D template and you're using surfaces and alignments and things like that, our template is set up to create their own individual layers for each surface and each other Civil 3D object. And that allows us to turn things on and off within the drawings as necessary. But when you're creating your own line work, it's highly recommended that you go ahead and create your own layers for that line work. And a nifty little trick is if you put a hyphen in front of the name of your layer, it will always show up at the top or near the top of your layer list, which in a layer list of 1,000 layers, that could be very helpful. So, layer names are based on something known as National CAD standards. So, putting that little hyphen in the front, while convenient, it does go slightly against National CAD standards. And those CAD standards includes a lot of abbreviations for things like civil, or structural, or architectural, or mechanical. Each one of those letter designations are for what type of object the layer should be on. So for this case, I'm going to create a layer and we're going to call it I for instrumentation underscore, I'll do all caps, V notch here. Now, one thing I'd like to point out when you're creating a new layer, and I did that by selecting this button here, and then I started typing in the information for the name, is that by hitting this button, it copied all of the settings from the current layer I was on. So I was on layer 0 when I started this command. And now when I hit enter, I've finished creating the I underscore V notch weird layer. But it copied every single setting that was on the 0 layer because that was my current layer. So if I started with my current layer as def points, which we remember is a non-plot layer, if I were to start a new layer, create a new layer with def points as my current layer, it's going to create a new non-plot layer with all the same settings as def points. Okay? And by the same token, if my current layer is CNOTLB, which stands for title block, and you see that the color is blue, if I were to go and change this setting here, any new layer is going to be based on those current settings. This is very useful for when you want a layer to be somewhat similar but have a different name to something that you already have in your drawing. Okay? Now I'm going to delete layer 2 and delete layer 1. And I've got this new layer I_V_notch weird. Now I want this puppy to not be on layer 0 and color 0. I want it to actually be by layer and on I_V_notch weird. Same thing with this stuff. I can want all of that to be on the same layer. This monstrosity we'll just get rid of, delete. So it's not terrible to come back in and add layers and to organize your drawing after you've already started, because a lot of times when you start working on something, you really want to get some stuff down before you really start getting your drawing organized. Come and bring it in if you can.
I'll bring it in.
Yeah, if you don't mind. All right, guys, we've got pizza being delivered here, so we may take another short break, but then we're going to start back with pizza in our mouths here in a bit. But so it's not terrible to go ahead and start doing your drafting and designing things, and then go back later and add those objects to an appropriate layer. But also be mindful that when working in the Civil 3D environment, that most of your objects are going to be on the appropriate layer anyways. And I'll give you an example here. This surface, sorry, let's go to the actual Civil 3D template. No? This was the drawing one. The drawing 3 was the one that started with the detailed DWG template, and so the surface itself did not end up on the appropriate layer. And so to maintain the sort of NCS CAD standards, I would start that with C dash. I could do surf, I could do 10, I could do topo, but I'll call that C topo EG, and then I could put that on the appropriate layer. So now it has its own surface. But just so you know, each one of these lines that represent the surface are on its own layer as well. The cyan lines are on a layer that's called C topo N for new, I believe, or there it is, C topo major N, and the yellow ones are on their own layer called C topo minor N. If I were to turn off or freeze those layers in this drawing, the surface is still there, and the data for the surface is still there, but those layers have been turned off and now are no longer visible. These are the polylines from the surveyor that were used to generate the surface. So now we're only showing the major layers, the major contour lines, because I've turned off those layers. Any questions about this stuff, guys? All right, guys. We're going to take another short break and allow people here to eat a little bit of a lunch. And then when we come back, we're going to start in on scale issues. This is where we're going to discuss basically structural versus civil scales for the most part. We'll talk about XREFs, and then the big one, data management. And before we sign off for today, we may touch a little bit on printing and CTVs. We'll see how far we can get. All right, guys, let's catch back up at, we'll do 12:45. That's going to give a 10-minute break for you guys and 10 minutes for a few people here to start eating, and then we're going to kick back off at 12:45. Thanks, everybody.